Let's work now on class discussion 1. So we actually have all the characteristics of an exponential functions based on the do now. So this one is just a formal definition of an exponential function. So I just want you to highlight the important parts of the definition of an exponential function. An exponential function is a function in the form y is equal to a times b, the exponent x. So highlight this one. And the most important part here that to make it an exponential function is the exponent x. So where a is the non-zero constant and b is greater than 0 and not equal to 1. This is a very important character. Remember in the do now that we tried when the base is equal to 1, it graph a straight line. So that is why it is restricted that for an exponential function, it can never be equal to 1, the base. The base can never be equal to 1. And x is a real number. And here are some of the examples. Now, on the do now also, we actually describe two different graphs of an exponential function. We have the increasing graph and the decreasing graph. Here we actually have a name for that. The increasing graph, we call that one as an exponential growth. Like on the do now, we identified that the base actually is greater than 1. Now, another way of expressing the base greater than 1 is that when you say 1 plus something, that is actually greater than 1. And here are the parts of an exponential growth. A is representing the starting amount, so that is actually when x is equal to 0. And x is the exponent, which is actually represents time. And time, it could be days, could be years, could be months, could be weeks, and so on. It tells about time. And this is very important when we deal with word problems, that you should be able to identify the parts there so that when you form the equation, you know how to set up the equation of an exponential function or exponential growth function. Now, for the exponential decay, we describe that one as the decreasing exponential function. We look at the graph. These are two inverse graphs. One is going up and one is going down. So this one is going up and the other one is going down. So that is an exponential decay. Now, the structure of an exponential decay is similar with that of an exponential growth. The only difference here is that the base. So just look at the base. If the base actually is between 0 and 1, as we have described it from the do now, then that demonstrates an exponential decay. And another way of saying that the base between 0 and 1 is when you say 1 minus something that is already less than 1, but it's actually greater than 1 also. So that is how we identify an exponential decay function. Let us now have example number 1. Identify the given function is an exponential growth or an exponential decay. And you're asked here to justify your answer. So for number 1, A, you are given y equals 500 times 0.96 raised to the exponent x. Now, I am looking at only the base. So the base here is actually 0.96, which is actually less than 1. So if the base is less than 1, we describe this function as an exponential decay. So I would say this one is an exponential decay because base is less than 1. And for number 1b, you are given y equals 500 times 1.28x. So I'm just looking at the base here. So this is the base, actually, the exponential function. And this one actually is greater than 1. So if it's greater than 1, I would say that this one is an example of an exponential growth. So I would say this is an exponential growth because the base is greater than 1. Okay, I want you to work now on try this on your own one. There are only 2 problems here. So identify the given function is exponential growth or an exponential decay. So the first one, I would say that this one, the base is greater than 1. So I would say this one is an exponential growth because the base is greater than 1. And for number 1b, I would say the base is less than 1. So I would say this one is an exponential decay because the base is less than 1. Okay, so this one completes, so try this on your own one.